Hello and welcome to this lesson about solving one-step inequalities. The learning target for this is how to solve one-step inequalities. Now, I want to start by talking about a big idea. Now, one thing that you may hear from me in class or from several of my other videos is that I like to say that half of algebra really is this right here. X plus 1 equals 2. And it's just a big old variation of x plus 1 equals 2. And you make things more complicated, but it boils down to x plus 1 equals 2. And this is no different. This is a prime example of that. So in an algebra class, you learn how to solve an equation. You learn this whole idea of like, all right, well, we'll do a little mirror line. We have to isolate the variable, get it by itself. And to do that, we have to balance out the equation using inverse operations. So you learn that idea. And then we'll take the exact same numbers, we swap out the equal sign for an inequality, and the process is pretty much the same. And so that's one thing I want you to take away from this, is that we have the same process as solving equations, except plus one more rule. And that rule, I'll write it in red because it's a big deal, which is that if you multiply or divide by a negative, you have to flip the inequality. So that's it. And again, just kind of keep it in, if we look at the big picture and keep it in context, the big idea, half of algebra is x plus 1 equals 2. And all we're doing is we're adding something else. We're adding one more step. And that's what we're doing with inequalities, is we're just adding one new rule, multiply or divide by a negative, you flip the inequality. But like I said, it's the exact same as equations. So for example, let's say we had something like x plus 2 is equal to 4. Well, now if we had something like x plus 2 is greater than 4, we're going to use the same mechanisms, the same idea. And so we would subtract 2 from both sides, and our answer is x is greater than 2. All right, now let's do something a little bit different, show you a slightly different look. Let's say we had 5 is greater than 6 plus x. So we still have to look at, what's the relationship between the 6 and the x here? And it's being added, so we'll have to subtract 6 from both sides. And I bring this up for a couple of reasons. One, you see a negative sign, you don't need to flip. Even when the answer here becomes negative, notice how the inequality stays the same, and it's just negative 1 is greater than x. Now, what you have to do is be really, really careful if you want to rewrite this so that you have the x on the left-hand side. The little catchphrase I have for this is think about peeling off a sticker. So if you were to peel off a sticker, how it's going to kind of rotate around like this. And so you'll get the x, and then the inequality is going to flip over as well to become less than negative 1. All right, think about just what you can do. Hold your hand in front of you, like on top of the screen, and then flip your hand. That's what's happening with the inequality. All right, it's going to flip just like that. But at the same time, if you wanted to, you could leave it as negative 1 is greater than x, and that's just as correct as x is less than negative 1. But we tend to like it in this form and find it more convenient. So just going to throw that out there. All right, so now let's look at another example. Let's say we have x minus 8 is less than or equal to 10. So we're going to add 8 to both sides, add 8 to both sides, and x is less than or equal to 18. So it's only when you multiply or divide by a negative that you're actually going to flip the inequality. And so let's get some examples of doing something like that. So let's say we have negative 2x is less than 16. Here, we need to divide by negative 2. Now that we have done something with a negative number, this inequality has to flip. That's my little symbol for flipping. X, and now it's going to become greater than negative 8. Box it, walk away. Now, be careful. Some people think, well, anytime you multiply or divide, and you oversimplify the rule, you have to flip. So if you had something like 5x is greater than or equal to, how about this? Negative 30. This one, guess what? You just divide by 5. You're dividing by a positive number. Even though there's a negative right there, that doesn't mean we flip. You have to, this number, the coefficient, needs to be negative. Since the coefficient is not negative, x is going to be greater than or equal to negative 6. All right, we got 2 more examples, and that's that. So let's say we have, a number of them, no, okay. X over 4 is less than or equal to 8. So here, our variable is being divided by a number, so we need to multiply by that number. And we're multiplying by a positive number, so everything stays the same. X is less than or equal to, and then here, 32. But we have something like x over negative 2 is greater than or equal to 4. Now we need to multiply by negative 2. And since we're multiplying by a negative number, we're going to have to flip our inequality. X is less than or equal to negative 8. Box it, walk away. So one-step equations, I really, again, just want to stress that idea. It's very, very similar to what we've already done with equations. It's that one extra rule. You have to multiply or divide by a negative. It's not if you multiply or divide into a negative, but it has to be by a negative. So like this one right here, or this one right there. Then you'll flip the inequality. So good luck with your homework and practice, and let me know if you have any questions.